Good evening, everyone. This is Niladri Chaudhary, CEO of Excellent Pro, and we have started this new service called Playground, the Virtual Dojo. This is a place where you can come and you can bring your business problem. We will help you to hypothesize and experiment and learn from it. And that's how you are going to learn and take it back to do it at your own home. And with me today, I have Kyle McMeekin, and he's the head of channel Gremlin. If you do not know Gremlin, I will just leave it at a chaos engineering tool and very popular today, but I will leave Kyle to explain the rest of it. So as part of the playground, one of the things that we are looking at is that we all see we want resilient systems. And if we want resilient systems, we need to break things. Also, as Mark Hornbeek says, you will not be a good leader unless you are comfortable to get your teams to break things. So in today's world, we need to break things to understand where the weakness is and take care of it. You all have seen the AWS S3 outage in 2017. S3 buckets were down. That's half the internet, and you can see so much of ruckus going on around that time. And 2017 is far off. Actually, as days progresses, we see more and more outages happening for everyone. Office 365 outage in 2019, Google outage in 2019. We had failures in Amazon, in Microsoft Azure, like a 3-hour outage just last year. We saw outage in WhatsApp, Facebook, many products that we use on the cloud every day, and we just get stuck. So failure is the new normal. It is going to happen. So how do we take care of it? How do we make sure that it doesn't affect businesses, it doesn't affect the customer's experience? We all accept that failure is normal, but not a great deal. So failures are inherent to complex systems and definitely will cause downtime unless we do something about it proactively. So you must have all seen this kind of a diagram, the Death Star. This is the Amazon Death Star. This is the Netflix. So many microservices, so many containers are fired every day. If you look at Google, Google fires 3,300 containers every day. So it is like impossible if we do not take care of them. So we need to be resilient. And if you see, speed of innovation is the competitive advantage. Otherwise, we are not going to just not survive. We will not grow, because survival is sustenance, but we cannot sustain if we do not grow. Without growth, our competitors will kill us. So as McKinsey said, time has come for IT to face the actual complexity required to really drive its own transformation. We have seen movement from waterfall, monolith, on-prem kind of scenario to DevOps, microservices, Kubernetes, making more use of more number of moving parts, more complex systems, more difficult to handle. We need to take more care for resilience. Now, traditional testing is just the tip of the iceberg. We know that you cannot do continuous delivery without continuous integration, and you cannot do continuous integration without continuous testing. So testing is important. Testing is becoming more and more important, more and more crucial. It's critical now. It's not just something we have to do. So whether we are migrating to cloud, whether we are training teams, whether we are shifting to the cloud native, whether we are mitigating dependency failures, verify monitoring, test disaster recovery, right-sizing your cloud, we need to try out proactively. And that's where chaos engineering comes into play, right? So as you see that there are multiple myths about chaos engineering. Many I have heard says we are not mature enough to start chaos engineering. That's not true. Netflix didn't start when they were mature, when they had a very good kind of a system, resilient system. They matured with chaos engineering. Our systems are too critical to do chaos engineering production. There are much more critical systems. Don't be so proud about your system itself. There are many, many systems which may be critical than us. So if they can do it, we can do it. Chaos engineering is about randomly breaking things. No. I've heard people say that people are given awards for breaking things. It's not for breaking things. The awards are for, by breaking, you have found a weakness in the system which you could take care of, which has led to more outage getting not happening, more outage not happening, reducing the outage so that customers are more happy, business is more happy. And chaos engineering is only for large organizations. No, anybody and everybody can do it. You can start with non-prod kind of scenarios and you can do it, right? So that is where I would look at and hand over to Kyle to start off with his session. And thanks again, Kyle, for your time and being partner in the Playground Dojo, for helping organizations to practice chaos engineering, learn from here, take it and use it in their organization.
Awesome. Well, thank you very much for the good overview and an introduction. And thank you for everyone for joining today. So my name is Kyle McMeekin. I head up the channel over here at Gremlin. So Gremlin, what we do is we focus on helping organizations ranging from small all the way to the enterprise build more resilient and reliable systems. So as we heard, these systems are becoming more and more complex. They're more hybrid in the sense that some applications are being built net new, fully cloud native, but organizations typically have old data centers or old VMs that they're running. So the challenge becomes, how can we take a more proactive approach and kind of validate, or for a lack of better word, do resiliency testing to make sure that if certain services go down, and these could be services that we as an organization have built, or these could be third-party services that you have no control over, right? You might be using a managed service container runtime environment, or you might be having, DynamoDB from your database perspective, and you don't necessarily have the control over if the systems are up or not. So what we want to do with chaos engineering as a practice is take a very prescriptive approach and help outline and kind of understand our architecture of our environments, and then start performing and injecting failures into those so that when things inevitably break, or we have issues that might be the fault of our own or even a third party that we're relying on, that our teams are well equipped to kind of handle those disruptions and keep some of these mission critical business applications up and running, not only for the end consumers, right, but for the internal functions of the business itself. So we'll take a look at what chaos engineering is if we advance the slide. And we talked a little bit about some of the myths around that, right? And we've a lot of teams have initially heard of chaos engineering, as it was alluded to earlier on at Netflix. So if you've heard of the tool Chaos Monkey, that was about 10 or so years back, and it's really matured since then into becoming more of a very reliable practice, and has advanced from just randomly shutting down servers, or you can think of an analogy of walking into a data center and just pulling random plugs. It's matured a lot since then, where now there's a very deliberate, almost calculated approach to the type of experiments that we're running, where we're running them, and the breadth and scope of which the impact of those experiments have. So by taking this methodical approach and layering in, information based on recent outages or architecture diagrams or validating alerts in your observability and monitoring solutions, it's really grown up and matured into something that a lot of organizations have adopted to help get ahead of any sort of issues that might rear their ugly heads down the line. So if we move along, we'll talk a little bit about what chaos engineering is. So as I mentioned, it's about taking various assumptions that we have about our environment, about our applications, and defining an explicit hypothesis around that. So for example, we might look at an architecture diagram and define a critical user path and say, hey, what if this particular checkout service went down? Or if I had an ad service that went down? As an end user, I would still expect to be able to use the application without facing any sort of ugly error messages or high load time of the website. So we want to kind of formulate some of these hypotheses and then apply from a chaos engineering, what we refer to as attacks, to validate those hypotheses. So I almost relate it a lot to exploratory testing, right? We're not randomly going in blind and trying certain things, right? We have a good understanding of our systems and we're forming some of these hypotheses that we then want to validate against. From there, what we then do is we start small and we grow what we call the blast radius. So the blast radius, from our perspective, is just the breadth and scope of which you're injecting the failure into, right? So a lot of times groups are like, hey, do I just let experiments run wild in my production environment and just see what happens? That's not the approach we would encourage, right? We typically want to start in a lower environment, maybe a development or staging environment. And we might start by validating some hypotheses around one or two services, right? Or we might validate auto scaling capabilities, or we might validate the alerts that we have set up. So we want to kind of start small. And as we get more comfortable with our system, we'll increase that blast radius and ultimately progress where we're running those tests through development, staging, and then ultimately production environment. So it's very similar to how, when you're doing QA, right? You're not starting in production. You're probably starting in a lower environment, running through your tests, progressing that code, and then doing some acceptance testing in the production phase, right? It's very similar from a chaos engineering perspective. And then another big thing is taking those findings and communicating them out so the needed actions can actually be taken place, right? So it's no good to say, hey, we have a dependency on this particular microservice, or hey, our auto scaling policy actually doesn't take effect until 60% CPU, but we thought it would actually take effect once it hit 70. So being able to take what you uncover through running some of these experiments is critical. So we give teams ways to report out and create issues and things like Jira and all of that, so that the findings that you uncover can actually be fixed, patched, and ideally you can kind of build out a regression suite of these experiments that you run. And then along those same lines, right, is having that practice where you're designing these experiments, you're building them into your build pipelines. So a lot of the efforts that teams take around doing like continuous testing, it's a very similar approach around the chaos engineering front, is baking this into those build pipelines. And then from there, right, the crux of it is that we're going to be very deliberate about these experiments, and we'll take a look at this, but they should all be designed to help pinpoint and kind of uncover any sort of weaknesses in our system. Again, whether those are our own services that we maintain or third-party ones that we have no control over, right? We want to understand where those weak points are and harden those to prevent any sort of disruption down the road. So the way that we do this is obviously by applying these chaos engineering principles, but there's a lot of what we call excuses that we hear, right? So some common ones would be like, hey, we don't have time to do this. We're already fighting fires. We're trying to restore systems. Things break by themselves. So why are we breaking them? And then one of my favorites is like, where do we begin, right? How do we get started? Where do we, do we review Sev 1, Sev 2 incidents? Did we have a big event that caused an outage that we want to avoid? Maybe, you see it all the time, even with some of the airlines, like a service goes down and people can't book flights, or, they can't access their itinerary. So being able to help mitigate these are all kind of excuses that we want to overcome. And we think, obviously systems, as we saw through those Death Stars of Amazon and Netflix, I actually think those were back in like 2016. So I can't even imagine how complicated those are now, right? So the idea is that, these systems, especially with the push towards the cloud and the evolution we've seen from Agile to DevOps to CI and CD, right? Like we want to get ahead of this and start practicing chaos engineering before these systems even become more and more complex. So with that, right, the way that we do this is through the practice of chaos engineering. So if we advance here, there's various elements around chaos engineering that we support. So we have things that we'll take a look at once we dive into the demo that allow us to take some of the principles of chaos engineering and actually apply some of these reliability tests that we want to build. Right. So if we progress forward here, we have various blast radiuses, right, which we talked about. So starting small with your initial test, perhaps on one or two services, expanding that blast radius, and then promoting this through various environments, right? So if we take a look forward, this is a good visual here on the next slide of how we would do that, perhaps, right, in a development environment where in the upper left, we're starting small, we're expanding that blast radius, and then we're rinsing and repeating that process across staging and production. And doing chaos engineering in production sounds daunting, right? But there's more of a crawl, walk, run model that we have that as you get more familiar with your systems, as they become more hardened, we give you the confidence to safely and securely run these type of experiments in that production environment, which in our opinion is very important, right? Because that's ultimately where your end users live, right? So being able to run and validate certain scenarios where your end users are is a critical part to doing chaos engineering and doing it effectively, but very common and almost advised for groups to kind of start in the lower environments until they have the comfort and expertise to run these larger scale production type chaos engineering experiments. Okay. And as I mentioned, this is a great quote. This is from James Hamilton. He's a pretty prominent engineer, but essentially without production testing, right, you're not going to know what to do when you're asked to do it. So this is one of the big things we're trying to help teams with is they often will, look into getting observability and monitoring solutions like Datadog and Dynatrace, or open source ones like Prometheus and Grafana, which are paramount, right, to understanding and observing your systems and what stresses are on those, right? But they don't necessarily do a great job of preventing issues from becoming issues to begin with. So we think that by marrying the efforts with observability and monitoring with some of the proactive work that you can get ahead of on the chaos engineering front allows you to really be alerted of what matters, right? And not being drowned out by a ton of noise, from those APM tools, and being able to configure alerts based on services or certain policies that you've configured that will cause an issue and that should be taken with the utmost priority. Okay, so in Gremlin, we'll take a look at this in a bit, but we have various types of what we call attacks that you can run. So some of these attacks would be resource failures. So this would be things like if we advance the slide a little bit, that allows us to say, hey, what if we spike CPU, or what if we filled up disk space, or what if we added latency right between certain calls and whatnot? How would our application and environment handle those? Outside of resource failures, if we move the slide forward again, we have what are known as service failures, right? So if we have certain microservices that go offline, this is a pretty common scenario where a lot of enterprises and teams will have, groups that are responsible for a subset of services. And oftentimes it's challenging to understand how those services interoperate, right? If I make one change to a checkout service, does that affect my currency service? So having a clear understanding of like where those service failures come in is paramount. Outside of these two, we also have what's known as like those dependency failures, right? Which ties in nicely to some of the service ones that we have. So being able to understand what the critical user path is, understand if there's any sort of interoperability between services. Those are all things that you can validate and kind of provide proof around, right, within and by applying chaos engineering. And then last but not least, application level failures. So a lot of the ones above are focused mostly on the infrastructure side, right? What if I spike CPU? What if I drop network connectivity? And then application wise, like injecting latency right between certain API calls, and perhaps marrying some of the failures you're injecting at the infrastructure level with some of the functional testing or performance engineering testing you're doing. And then the cherry on top is taking all of these different practices and then baking them into more of a continual process, right? By building out almost like a regression set of chaos engineering or reliability tests that you then run every time you do a Jenkins build, or if you're using Bamboo or Azure pipeline, like just having a continual way to do this, which we think is the best practice, right? It's not good enough, in our opinion, just to prepare and do a chaos engineering test, in lieu of a big holiday sale or a big promotion, right? We believe these are things that should be done on a regular basis, very similar to how you would, continually test from a functional perspective, how your applications and whatnot are performing. So as far as it working, right, before we jump into the tool, we'll share some examples here and kind of walk through this. The first one that we have is with Backcountry, right? So they had a big SLO breach back in 2017, right? Ultimately, from that event, that was kind of the catalyst to start them off of actually adding more latency, right, between certain service calls within their app to help ensure that, if an influx of users came to the site or if things weren't performing as they were expecting, it wasn't going to, break anything as far, in this case, of which robots and whatnot they use to catalog and provide, various SKUs and whatnot to the consumers on their website. Another example would be with MailChimp. So this is a great one that was really interesting to see, where they essentially came and said, hey, we have, this is our website, this is the architecture. And as we're going through and performing experiments on it, there's a misunderstanding that, hey, this particular service, it's not of that much importance. So, we don't harden it. It kind of just hangs out. And what they realized is that when they drop network connectivity to that service, which you can do through a black hole attack, right? It essentially renders it unreachable. It actually aired out their entire website, right? And they would have no real understanding of that without performing chaos engineering and kind of validating some of the architecture diagrams that they've built, right? So these are some of the learnings that you can get, by applying some chaos engineering principles within your applications and environment to get a better understanding of how hardened they truly are. Okay, so with that said, I wanted to spend just some time quickly kind of running through an example of this in practice. So let me go ahead and share my screen, and we'll kind of walk through and take some of the foundations around chaos engineering and see how it works in real time. So to do this, there's essentially three core things that we have or that are needed within, a typical enterprise or just even an SMB based company, right? One is access to Gremlin. So Gremlin is a full SaaS provided platform. We're hosted on AWS, and ultimately what we're able to do is use Gremlin's interface or APIs to pinpoint and inject failures into an application. So for today, I'm just using a very basic online retail shop. This is an open source app that has various microservices that are running, right? This is what it looks like from an architecture standpoint. Users come in through the internet to the front end, where they're then greeted with a bunch of products and items that they can purchase, right? There's recommendation services, there's an ad service. So we can see a lot of these right up top. There's a currency service to dictate, what the cost is. If you select a certain item, you get recommended items down below. You get an ad that gets served up. So what we're starting to do based on some of the principles that we outlined earlier in the talk is we want to start forming certain hypotheses around what would happen, right? So basic one might be, hey, this ad service based on this diagram doesn't appear to be instrumental, right, to the end user experience. So in the event that it goes offline or isn't reachable, like I, as a user or a business, would expect that someone could still come in, add an item to the cart, pay for that item, and not have any sort of disruption, right? So we'd start forming multiple hypotheses around this, and then we would use Gremlin to actually validate some of those assumptions that we have, right? Another one might be like, hey, if the payment service wasn't online, like, could I still purchase an item, right? I mean, if the end user doesn't have the ability to enter their credit card details and actually make a payment, I probably can't check out. So I might want to focus on this one and kind of harden that. So we'll take a look at how we design some of these tests. And then a big component of it as well is like the observability and monitoring solution. So as we're injecting CPU, or if we're injecting latency into a particular service, we want to lean on some of the capabilities within groups like Datadog or New Relic or Dynatrace or some of the open source tools to get an understanding of how our system is impacted by those tests that we're initiating from Gremlin side. Okay. So the way that Gremlin works is, we have our SaaS edition, right, that you can go in and access the interface on. And then we operate through an agent-based install. So these agents hang out within, the customer's environment or your environment. You can install the agent on a VM. You can install the agent into a containerized environment. If you're using Kubernetes, you can put it up in an EC2 server. But essentially that agent hangs out where your applications run. And that agent will detect all the services that are running, right, where it's installed, and start indexing and cataloging them here for you in Gremlin's interface. So we'll see, frequent ones like the ad service, cart service. A lot of these just get rendered in based on what our agent can uncover, right, in this given retail application. And then from Gremlin, you can go in and see like, hey, this is running in a Kubernetes environment. These are the type of attacks we've run. These are various dependencies of that service. So we'll index them all here and then allow you to start forming those attacks that we talked about, right? These would be the resource, state, network type attacks that we have access to within Gremlin. So if we create a new attack, we can either choose to inject failure in at the host layer, container level, or in this case, since we're running this with Kubernetes, I could go down and just find particular services that I want to run a particular experiment against. What you'll notice on the right-hand side is we have something called the blast radius, right? So this is what I was talking about earlier, where we can very easily visualize and kind of dictate the scope and reach of which this particular failure that we have, how far reaching it will be, right? So in this scenario, I'm just doing it on this one particular service. As I get more comfortable with this service, I could perhaps choose other ones that I would also want to run a particular attack against. And again, the idea is that as you get more comfortable with these particular services, you increase this blast radius, right? And then iterate that through various environments, right, where these applications are running. So in this example, we're going to use the hypothesis that I formed earlier that essentially said, hey, if this ad service goes down, I would still expect to be able to check out items as an end user. When we go down below into this attack area, we have those three categories that we talked about earlier. So we have resource-based attacks, which would allow me to do things like, hey, I want to spike CPU. Maybe I want to validate my auto-scaling policy, or I want to fill disk space, or I want to alter the memory on a particular server. We have state attacks, which would allow me to do things like, hey, I want to shut down a particular process on a VM and just see how things get handled. Or I want to validate my certificates expiring and do a time travel attack to make sure that, if they do expire, then I know what happens and I know how to restore the system. And then the last but not least category is these network attacks, which are probably our most popular and would allow you to do things like black hole a service, which again is making it unreachable. So this is great for services you own, or, if you wanted to simulate an AWS region or something like that going down, right? Like you can do that as well, where we essentially drop network connectivity to it and allow you to kind of understand what would happen, right, to your apps and infrastructure if one of these providers, for whatever reason, had some sort of outage. So there's all types of advanced type of configurations you can do here. If you wanted to drop network access with this black hole attack, to a particular IP or port or host name, those are all advanced configurations that you can do. But how this then works is when you unleash this gremlin, right, our agent will reach out back to our control plane and say, hey, is there something for me to do? Right. And in this case, it's going to find this particular ad service running in this Kubernetes environment, and it's just going to drop network traffic to it. Right. I chose to run this for a minute. Outside of that, there's a lot of like safety and kind of guardrails that we put in place, contrary to how chaos engineering was done in the past, where you kind of just let things run wild. Right. You have full control over to like halt attacks and revert the environment back to a stable state. If you perhaps made some sort of mistake, or even if that agent loses the ability to communicate back out to Gremlin, we'll revert that environment back for you. But now that this is running, the typical flow would be, hey, I'm going to head back to my app. I'm going to validate my hypothesis. You can notice now if you caught it earlier, that banner, the pink banner down below with the ad service is no longer present, right? That's because Gremlin's essentially bringing it offline. And I'm going to validate my hypothesis, right? So I'll add a couple pairs of sunglasses to my cart. I'll go in, see my total. I'll fill out my billing information, credit card details. That ad service is still not there. And I'll place my order, which goes through successfully, right? So what we're doing is just proving out that, hey, based on this architecture diagram, there's no sort of disruption. If this ad service goes down, right, as an end user, I can still easily go through and make, a purchase on the site without any sort of problems. And then the idea is you'd kind of rinse and repeat this process and form additional hypotheses, right, around, assumptions that you have, or perhaps based on, a knowledge repository of known issues that have keep rearing their head, right? So we want to kind of harden additional systems and services to make sure that there's no sort of end user disruption, right? So if we took a look at this, we could form another attack, perhaps this time on a payment service, right? So, hey, if I, for some reason, was trying to make a payment, maybe if the service was online, but there was a high degree of latency, would the purchase still go through, right? Would the end user experience any sort of strange message? Would the purchase write properly to a database, right, that we have to track orders? So I'll go ahead and inject, in this case, maybe 500 milliseconds of latency into this particular service and unleash the gremlin to start running it, right? So this is going to go out and run a particular latency test against that payment service, and we would rinse and repeat the process, right? So I can come back into Gremlin just to show you here, like the ad service is back, right? We restored that after black holing it initially. And this is where a lot of the monitoring solutions and all that come into play, right? Because I can jump into my Datadog account and I can see that payment service is experiencing a high degree of latency. I threw 500 milliseconds of latency at it. So we can start seeing these spikes transpire on these particular services. Again, really fine-grained control over which ones we're attacking and targeting. And then we validate the functionality within the application under test, right? So I'll go in here. This costs, $24. I'll place the order, and you might not have caught it, but it hangs slightly, right? It wasn't as quick as my previous one, but again, no issues there. So like we can start to feel comfortable that, hey, even if a particular service that's as important as the payment service is experiencing some sort of problem, right? It's not, 500 milliseconds of it won't cause any sort of weird error message or 500 error, right, for the end user on the site. So you'll take some of these very simple kind of singular points of attacks, and what you can then do is start blending them into what we call scenarios, which are more comprehensive, like end-to-end based tests that you want to run. So some of these scenarios come recommended. All right, popular ones like, hey, I want to validate auto scaling, so let me check out what this does. And essentially what we're doing here is we're spiking the CPU to 100%, right, across a particular capacity for a minute, waiting 5 seconds, doing it across a capacity of 10 for another minute. And we're rinsing and repeating this to make sure that whatever auto scaling policies we've configured actually work in the way in which we think they do, right? So it's not atypical for us to work with the group to say, hey, when we hit 70% CPU, we spin up 3 more pods, and there's no real way for them to know if that actually happens or not, just by trusting it, right? So they want to be able to prove out and kind of have proof points that everything's designed and working as they're expecting, opposed to facing the situation where they actually are in production and they don't auto scale because the way in which they configured their Kubernetes environment wasn't what they thought it was, right? So these scenarios come recommended, and then we give teams the ability to build their own if there's certain situations and whatnot that you want to account for within your own organization. Another great part about these scenarios is we essentially put them in a conditional loop. This is a good way to think of what we call our status checks. So what we're essentially doing here is saying, hey, while we're running through and spiking CPU, at any point, right, if we don't receive a response back within a second, or if we don't get a 200 API response back saying it was successful, stop the experiment, revert the environment back to its stable state, and and conclude, right? So these are just helpful ways in which we could, one, ensure that as we're running the test, nothing gets out of control, right? That we don't have safeguards around. And then secondly, and arguably more importantly, making sure that, hey, before we start injecting some of these failures into our environment, let's make sure we're not adding issues to a system that's already experiencing some sort of problem, right? So these status checks are a great way to do that, to make sure that you're not having some sort of like problem within your observability monitoring solution, and then on top of that, trying to add latency or bring a particular service down or whatever that might entail. So that's a very kind of quick rundown of like some very, very simplistic ways that you would use it. And as we were discussing, I mean, this can ultimately be used for a variety of things, right? Ranging from service dependencies to disaster recovery and business continuity planning. So we work a lot with groups, that have some sort of governing body that mandates, hey, we have to prove out resiliency, right, within these applications before we push them to the public cloud or before we release them to the public. Like we need to validate, essentially our underlying infrastructure to account for situations that might come up down the road and extend just beyond the application layer more into the underlying infrastructure layer that's doing the hosting of these various apps and services. So I'm just reading a quick question.
Everyone can send your questions by typing it here. So there's a question from Vishwanath Venkatesan. He says, in an agile setup where everything is shifting left and you have suggested to have continuous chaos, would you suggest that resilience be added as part of the DoD of a feature or epic level? In Kyle's experience, how has he seen it being done?
Yeah, so that's a great question. And it's definitely something we would encourage, right? I think like a lot of times teams are using, let's just take Jira, for example, to plan out their sprints and define epics and all the features at that layer. We see the most successful organizations that deliver those is by having some sort of mandate or initiative around resiliency to say, hey, before this feature goes live, we're going to test, everything, not just if it works functionally or if it can handle an influx of virtual users, right? We need to make sure that the feature we're designing doesn't have any sort of additional downstream effects on other services that have been running smoothly. So yeah, it's not atypical. It's, in my opinion, would be almost recommended that, hey, before code goes live and we release it to the public or our consumers or even internal business stakeholders, that we have a way in which we can prove out the resiliency of that new feature and the underlying services that it has. So teams will, typically add that as a proof point within that story, right? To kind of check off that, hey, we've done resiliency testing and we have ways within Gremlin that if you have a problem, and let's say, for instance, that ad service did cause some ugly user experience, that I could then create a Jira incident from that and communicate it out to those stakeholders that, hey, functionally that you think this is working, but in reality, there's some third-party services that we can't get over. I know there's another question around the databases, right? And how do we do the connectivity pools and errors like that? So for databases, a popular approach would be using a black hole attack, right? So for this Redis DB that we have here, I could essentially bring this offline by making it inaccessible. So even if I'm adding items to my cart and this isn't, available, what happens, right? Do we have some sort of caching mechanism? How do we validate that essentially what users are doing in the interface is still getting written on the DB level, right? Those are additional things that you can flesh out by running black hole attacks or essentially dropping that DB from having access to the actual application itself, right? But those are all things that you can kind of get ahead of and prepare for, even if you don't own those databases, right? It could be like a DynamoDB or something, right? Where you don't have core access or root access to it, but you can drop connectivity to it to kind of mimic if that company or provider had some sort of
ideal connection can be reused.
I'm trying to understand the question.
Srinivas, can you just give some more details on this, on your question? So Kyle, once you are done, you can stop the sharing.
Okay. Yeah, I'll stop it now. So it's just, that's a very quick rundown. I mean, hopefully it showed how we take some of the practices and concepts of chaos engineering and apply it right to these type of situations. So there's obviously a lot more. I mean, this is a pretty simplistic architecture diagram compared to those death balls, but the effort looks the same, right? It's kind of understanding what those critical paths are and forming some of those assumptions and then validating them by injecting failures into very specific points. But obviously, if there's interest to learn more, or if there's questions that the team has specific to certain environments and how they're set up, we'd be happy to field those, and we'll have our contact details here so you can reach out and to me personally, and I'm happy to get those addressed.
Srinivas, could you just explain a little bit more on your question? Ideal connection, can we reuse?
My question is, okay, when we have multiple connections connecting, okay, in couple of 1 minute or maybe 2 minutes, 100 connection we received. Later on, we received more than 1,000 connection suddenly in the peak time. So whatever have previous connection, can we reuse that any technique we have? Ideal connections. I'm talking about the ideal connections because the connection will be not create more. It will not burden the container something services server.
Right. So you're saying almost having a way to identify what those legitimate connections are and being able to be kind of recommended to use those ones for, moving forward. Is that more along the lines of what you're? Okay. Yeah. Yeah. So you can, within Gremlin itself, like you can see the connection pools, and you could black hole like particular connection IPs or ports to kind of mimic what those scenarios would be. So you would typically do that through more of like the advanced configurations. It doesn't go as far as like running a set of chaos experiments and then, briefing you of like, hey, here are the go-to connection pools to use and which ones are stable and which ones are not. It's more probably higher level and abstract than that, just to say, hey, these ones were valid, these ones weren't, and giving you the ability to have a firm understanding of what works and what doesn't. But I can follow up with more specifics as well, if that would be helpful, or use cases.
So Yogesh has another question, but before that, let me just take a minute. So just to extend further on the playground, you can see that you can come here and practice how to experiment and learn how to do chaos engineering. What are the concepts? What are the game-based concepts and so on using Gremlin? But along with that, there are many other things which is required today, like the continuous observability for security and compliance with a product from dfactor, looking at application security, orchestration and correlation from the DevSecOps point of view. We have Mavericks, where you can set up the entire DevSecOps pipeline and how to correlate the data from the different areas. We have threat modeling. We have value stream management from digital.ai. So all of these are available in the playground. So if you are interested, you can join us here. And we also have the DevOps India Summit, the largest DevOps and SRE event from India, globally known and well acclaimed. So this is this year on 26th of August from 8 a.m. to 8 p.m. Let us go to the next question from Yogesh Agarwal. I see this chaos engineering is on the platform side. How can we replicate this at the pre-prod or development stage, or this is just a user experience level in production?
Yeah, so good question there. So it is definitely more on the infrastructure side, right? And we would encourage teams to start in a pre-production or development type environment. I think the biggest challenge we see there is as much as you want it to be, like those environments are not production, right? So, do you have the same type of configurations? Are you still applying the same sort of like auto scaling policies? Because maybe you're trying to reduce costs and not have a lot of burn there. But more often than not, yes, you would start in pre-prod or development. And the situations that we ran through today did require me, right, from a practitioner standpoint to jump into the application and kind of validate things as they were running in parallel from Gremlin, right? A lot of the times as teams get more advanced, they actually rarely use the Gremlin interface, and they'll use some of the APIs to invoke and craft the various attack types. And then they have ways to pull some of the metrics from the observability and monitoring tools to kind of get a more of a concrete picture of what happened, right? So the situations we were running through today were very basic, and yeah, they do require, hey, the ad service is down, so let me jump into the application under test and validate that, right? But as you kind of mature, there's ways to pull like reports or do it in a more automated fashion where you're not bouncing back and forth between, the application under test and Gremlin and monitoring, to kind of consolidate everything in one single pane of glass, which would be Gremlin, where you can get a lot of the analytics and Datadog dashboards and all of that, where you can then review them and create incidents as needed.
Question from Madhujit Kumar: how we can maintain the server when CPU goes high and the system goes down?
Yeah, so I think, chaos engineering is more, the practice of it is more to understand, right? Like what would cause the system to go down at what level of CPU, right? And validating some of those assumptions. So it's not necessarily, hey, we're going to inject a high degree of CPU and then, fix everything in your environment. It's more to alert you that, hey, this will be a problem. If CPU goes high, your app will go down. And this is the specific threshold in which that will happen, right? There's some other great tools in the market that have done more on the remediation side. So if you've heard of Sedaya or Sosivio, are two tools in particular that come to mind that actually apply a fix, right, to your Kubernetes environment by running a command and restoring that to kind of avoid any sort of downtime. So I think it's kind of marrying the discovery and kind of uncovery phase of what you can find out by applying chaos engineering, and then having a good plan in place to say, hey, when this does happen, we know for a fact, right, the system will go down. So to avoid that, maybe we, increase our auto scaling policy, or we do other types of actions to help avoid that. But the intent with applying chaos is so that you have, essentially proof in the pudding of what causes those outages and where and what thresholds they'll be hit at, so that you can take needed actions to avoid those issues from coming up, right? Once they're live. Like ultimately what we're trying to avoid is people getting woken up at 2 a.m, from a page that says a particular system's down, and then they're scrambling and running around to try and figure out how to restore it and why it went down. So being able to do chaos engineering to, understand those proof points from the get-go is an important part of it.
Any other questions from anyone else?
Cool.
Okay. How do you solve the network issues within system with high usage?
Yeah, so a good one for that, Yogesh, would be adding a lot of latency spikes and whatnot with Gremlin. So like you could spike, the milliseconds or the latency between certain calls or on a container or a host by a degree that you specify to help get an understanding of it. We've got a really good example with a financial open source microservice app where if we drop the balance service, which essentially tells the user how much money they have in their account, right? If that goes offline and they send a payment to a friend, that payment error is out, right? And they get presented with some strange error message in the UI. So you can, again, kind of understand, hey, at what point, would this error message rear its head? Would a user think they have no money in their account? So again, you're kind of using the practice of chaos engineering to crystallize, what type of network issue would actually cause an outage and cause a disruption to the end user experience, and then applying fixes to help mitigate that and avoid it. So that you would ultimately use like a range of different network, state, and resource attacks to kind of mimic these type of scenarios and have an understanding of how the system behaves.
Thanks, Kyle. So as I mentioned in the beginning, that chaos engineering is not about just breaking things, it's a learning. How do we find weaknesses? How do we learn more about our system? How do we understand whether even our monitoring and observability is enough? How do we find out dependencies? How do we see how to improve throughout the pipeline? We are looking at trying to achieve that. And that learning is what Gremlin helps you to achieve by practicing chaos engineering. So with that, I think we will close today's session. Thanks, Kyle, once again, and for your time and for taking this
Yeah,
session.
absolutely. And I will, I'll share my email in the chat if there's additional questions or inquiries, or if this resonates, feel free to reach out to me and we can spend some more time kind of walking through more thorough examples. But thank you, Laundry and team, for hosting this. I really enjoyed the opportunity to speak, and thank you all for joining wherever you might be in the world, if it's later, earlier, whatever. Appreciate everyone's time.